Hello and welcome to the first tutorial series on HAROS, the High Assurance ROS framework. In this video we will be going over some exercises related to computation graph extraction and architectural queries. These are exercises that are related to the automatic extraction of models from the source code, but in order to enable this feature we must first follow a few additional preparation steps. Many of these steps assume the use of the Docker image provided in this repository and are made substantially easier if you do use it. The first step is to build a compilation database file for the Fictibot workspace, and this is automatically done with the Catkin script that is already available in the Docker image. Step 2 is to prepare some configuration files for HAROS, which again is already done in this image. Step number 3 is to define the models that we want to extract in the project file that we pass as input to HAROS. Again, this Docker image and this repository already have some example files where this section is pre-populated. Step 4 is finally to run HAROS now with a modified command that takes in an additional option to enable model extraction. Do note that this model extraction procedure takes a significant amount of time, especially when running for the first time or if the source code has changed substantially since the last run, because it takes essentially the same time as it takes to compile the code with Catkin when running the make script. Once you are done compiling with Catkin as usual, and after making sure that you have generated the compile commands JSON file, you source the workspace again as usual, and then everything should be ready to run the new HAROS command with model extraction enabled. Again, a reminder that this is going to take some time to parse all the source code. And once it is done compiling everything, we can open the visualizer webpage as usual and navigate now to a new models tab that will show us the graphical representations of the ROS architectures or the computation graphs. Here you can explore a number of things such as the types of the topics or where they are being used in the source code. The same thing for nodes. You can check their types and in which launch files they are being created. You can also inspect parameters which are hidden by default because they tend to make the graphs too large for comfortable visualization. Here on the left you can change which model you are viewing at the moment, and these are all the models that are declared in the YAML project file that you pass as input to HAROS initially. And this is it for the setup. From this point onward we are going to use a convenience script that comes bundled in this Docker image instead of typing out the HAROS command every time with all the options. Now, as you can probably guess, some of these problems and exercises are deeply related to the system that we are analyzing and what it should do and what it should look like in terms of the software architecture. So we recommend that you spend some time getting familiar with the Fictibot architecture before going deeper into the exercises. For instance, we have here a model that we can visually see that it has some kind of problem, because then the documentation states that it's supposed to be launching 2 independent robots, but under two different namespaces. But if we inspect the extracted model, we can clearly see that there is a topic that is being shared between the 2 systems here at the bottom, and this is clearly not intended. You can see another issue in a different model, in the safe random walker configuration, in which the velocity output of the random controller is supposed to be connected to the input of a multiplexer, but it is publishing to no one, essentially. So there is something going on, the topic is disconnected when it should not be. In the following exercises, we will be seeing some ways to detect this kind of problems and some ways that we can commonly fix them as well. For the first exercise, we are going to be addressing an issue that is automatically reported, that in the random controller package a topic is being advertised with a global ROS name. So if we check the issues page, there we go, the command velocity topic is being advertised with a global ROS name in this file location. So let's check the corresponding source code, and there we go. There is the name starting with a forward slash. And global names are not recommended because they make it harder to use namespaces in your ROS systems. And as we've just seen, there was an issue with 2 different robots under different namespaces. So our task is simple. Let's change the global name into a relative name and inspect the launch files to see if any remap tags need to be changed as well as a consequence of this change. Instead of manually inspecting all the launch files, we can use, for instance, a simple grep command that will quickly tell us that there's nothing to worry about. The topic name is always used with a relative form. Just scrolling over the suggested solution steps, we can confirm that indeed this is what we have just done. The only thing that's missing is to run the analysis again and confirm that the models have changed. Alright, it's looking better now. We can clearly see that the 2 systems are separated and independent from one another. They no longer share any topics. And the other system seems to have changed as well. The previously disconnected topic is now pointing towards the right subscriber. Moving on to the second exercise, we are now going to see some ways of detecting this kind of problem without relying just on manual inspection. We are going to automate the detection of these issues using a query language that will detect undesirable patterns. You can check the documentation for further information on the scope and capabilities of this query language. Right now we are going to delve right into the solution of the problem. And our task specifically is to write a query for the multiplex system that detects multiple publishers on a single topic. The first thing to do is to open the project file, navigate to the correct system, and then add this new user data section in which we are going to provide additional inputs for Haros and its plugins. In this case, we will be providing a new query to run. You can find a short explanation for this query here on the documentation. And now we are going to run the analysis again and see if anything new comes up. So let's refresh the visualizer and move on to the description of the second part of this exercise, which tells us to go to the runtime issues of the visualizer. There we go. We can find here two new entries stating that two topics have multiple publishers in the multiplex system. This is not supposed to happen according to the documentation, so there's something fishy going on here, probably some missing remappings or something along those lines, which we will be inspecting now. Let's just find the faulty topics and inspect them. There we go, the first one clearly has two publishers. And since we have already fixed a problem with the global name for this topic, it seems that it must be a problem in the launch file. Let's open the launch file and see what's going on. Indeed, we can find here a declaration of the random controller node, but it is missing the remapping that it is supposed to have to redirect the publisher into the subscriber of the multiplexer. There's another topic with the multiple publishers, but this time, if we inspect the details of this topic, we can see that it has multiple locations in the source code and also multiple message types. Again, let's look into the launch file. Well, the issue should be obvious. We have two topics being remapped to the same one. It's clearly a copy and paste error in which the developer forgot to change the final name in the second entry. The solution then is to add the missing remap to the first node. Let's go ahead and do that. And for the second problem, we only have to change the remap name to the correct one. With that, everything should be working as expected. Let's run the analysis again. Refresh the visualizer. Check on the runtime issues again. There are no issues. Let's check the models. And we can now see the correct topic remappings being applied. The random controller is targeting the subscriber of the multiplexer, and the safety controller has its expected two different topics being published. That concludes this short section on model extraction and architectures. Stay tuned for the next video.